Hi everyone and welcome back to the Comptia Network Plus course, Switching Loops. Today's networks often connect switches with redundant links to provide for false tolerance and load balancing. Protocols such as Spanning Tree Protocol, STP, prevent switching loops and simultaneously maintain fault tolerance if STP fails. It takes some expertise to configure and repair the network, so you just need to be concerned about being able to identify the problem so you can escalate it. Remember when you hear users complaining that the network works fine for a while, then unexpectedly goes down for about a minute and then goes back to being fine. It's definitely an STP convergence issue that's pretty tough to find and fix. Missing routes. Routers must have routes either configured to learn to function. There are a number of issues that can prevent a router from learning the routes that it needs. To determine if a router has the route to the network in question, execute the show IP route command and view the routing table. This can save a lot of additional troubleshooting if you can narrow down the problems to a missing route. Routing loops. Routing protocols are often used on networks to control traffic efficiently while preventing loops that happen when a routing protocol hasn't been configured properly or network changes didn't get the attention they deserve. Routing loops can also happen if your network admin blew the static configuration and created conflicting routes through the network. The evil event affects the traffic flow for all users, and because it's pretty complicated to fix, again, it's up and away with this one. You can expect routing loops to occur if your network is running old routing protocols like Routing Information Protocol RIP or RIP2. Just upgrading your routing protocol to Enhanced Interior Gateway Routing Protocol EIGRP, Open Shortest Path First, OSPF, or Intermediate System to Intermediate System will usually take care of the problem once for all. Anyway, escalate this problem to the router group. Routing problems. Routing packets through the many subnets of a large enterprise while still maintaining security can be a tremendous challenge. A router's configuration can include all kinds of stuff like access lists, network address translation, NAT, port address translation path, and even authentication protocols like remote access, dial-in user service, radius, and terminal access controller access control system, TACACS. Particularly diabolical errant configuration changes can trigger a domino effect that can derail traffic down the wrong path or even cause it to come to a grinding halt and stop traversing the network completely. To identify routing problems, check to see if someone has simply set a wrong default route on a router. This can easily create routing loops. I see it all the time. These configurations can be highly complex and specific to a particular device, so they need to be escalated to the top dogs. Get the problem to the best sysadmin in the router group, MTU Black Hole. On a WAN connection, communication routes may fail if an intermediate network segment has an MTU that is smaller than the maximum packet size of the communication host. If the router does not send the appropriate Internet Control Message Protocol ICMP response to this condition. If ICMP traffic is allowed, the routers will take care of this problem using ICMP messages. However, as ICMP traffic is increasingly being blocked, This can create what is called a black hole. This will probably be an issue you will escalate. Bad modules. Some multi-layer switches and routers have slots available to add new features. The hardware that fits in these slots is called a module. These modules can host fiber connections, wireless connections and other types as well. A common example is the Cisco Small Form Factor Pluggable SFP Gigabit Interface Ethernet Converter GBIC. This is an input-output device that plugs into an existing gigabit Ethernet port or slot, providing a variety of additional capabilities to the device hosting the slot or port. Conversions can happen in all types of cables from Ethernet to fiber. For example, like any piece of hardware made by humans, the modules can fail. It's always worth checking if there are no other reasons a link is not functioning. Proxy ARP, Address Resolution Protocol. ARP is a service that resolves IP addresses to MAC addresses. Proxy ARP is just wrong to use in today's networks, but hosts and routers still have it on by default. The idea of Proxy ARP was to solve the problem of a host being able to have only one configured default gateway. To allow redundancy, Proxy ARP running on a router will respond to an ARP broadcast from a host that's sending a packet to a remote network, but the host doesn't have a default gateway set, so the router responds by being a proxy for the remote host, which in turn makes the local host think the remote host is really local. As a result, the local host sends the packets to the router, which then forwards the packets to the remote host. Most of the time in today's networks, this does not work well, if at all. Disable Proxy ARP on your routers and make sure you have default gateways set on all your hosts. If you need router redundancy, there's much better solutions available than Proxy ARP. This is another job for the routing group. Broadcast storms. When a switch receives a broadcast, it will normally flood the broadcast out all the ports except for the one that broadcasted came in on. If STP fails between switches or is disabled by an administrator, it's possible that the traffic could continue to be flooded repeatedly throughout the switch topology. When this happens, a network can get so busy that normal traffic can't traverse it, an event referred to as a broadcast storm. As you can imagine, this is a particularly gruesome thing to have to troubleshoot and fix, because you need to find one bad link that is causing the mess while the network is probably still up and running but at heavily congested crawl. NIC Teaming Misconfiguration. NIC Teaming, also known as Load Balancing Failover (LBFO), allows multiple network interfaces to be placed into a team for the purpose of bandwidth aggregation and or traffic failover to prevent connectivity loss in the event of network component failure. The cards can be set to active state, where both cards are load balancing, or active passes, where one card is on standby in the case the primary card fails. Most of the time, the NIC team will use a multicast address to send and receive data, but it can also use a broadcast address so all cards receive the data at the same time. If these are not configured correctly, either they will operate at a severely diminished capacity, or worse, neither card will work at all. Power failure, power anomalies. When you have power issues, Whether it's full-blown power outage or intermittent power surges, it can cause some serious issues with your network devices. Your servers and core network devices require a fully functional UPS system. Step 6. Verify full system functionality and, if applicable, implement preventative measures. A trap that any network technician can fall into is solving one problem and thinking it's all fixed without stopping to consider the possible consequences of their solution. The cure can be worse than the disease, and it's possible that your solution falls into this category. So before you fully implement a solution to a problem, make sure you totally understand the ramifications of doing so clearly. If it causes more problems than it fixes, you should toss it and find a different solution that does no harm. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.